Hello everyone, welcome to this session. We're still discussing about the different kinds of the simple machines. So far in our previous video, we listed them like as follows. We said there are various types of simple machines. There is levels, pulleys, inclined plane, the screw and the screw jack, wheel and axle, and this hydraulic press. So far, we've covered the levels. We've seen all the three kinds of levels: first class level, second class level, and third class level. So today let's discuss about the pulleys. A pulley, this is the grooved wheel, which is free to turn about an axle that is fixed in a frame. So that's the definition of a pulley. This is kind of a simple machine that is having the grooved wheel, which is free just to move or to turn about the axle. Axle is like a fixed point in a frame. Now there are types of pulleys. The first one, the single fixed pulley, then there's single movable pulley, and third one is the block and the tackle system of the pulley. So these three are the three types of the pulleys. Now the first one, this is the this is the type of the pulley whereby effort is applied at one end of the tape in order to raise the load. So this is the single fixed pulley. This is how it looks like. It's kind of a pulley that whereby the effort is applied at one end of the tape. As you can see here, here is the effort where it is applied in order to raise the load that is found at the other end of the pulley. Now, the single fixed pulleys are used to raise small objects. Take an example, flags. So the flags are, are just raised by this kind of a pulley, single fixed pulley. Now consider the diagram as we've seen before. So the flag can be put like in here or right here. Then the effort is applied at the other hand at the other end. So when you pull the foot, when it's applied here, then the load goes up. And that's how, take an example, the flag is raised at the top of its pole. I hope that's clear. Now let's see the mechanical advantage and the velocity of this, the single fixed pulley. First we have to know that the effort in this pulley is equal to tension, is equal to load. But the mechanical advantage generally is load upon effort. Now in this single fixed pulley, MA is just equal to the VR, that is the velocity ratio of the machine. The velocity ratio equals to distance moved by effort over distance moved by load, abbreviated as force V R equals to X upon Y. Let's move on to the second one, that is the single movable pulley. A single movable pulley, this is the one which load is multiple of the effort. So in single movable pulley is the one whereby the load is just the multiple of a effort that can be applied. So as you can see here, consider the diagram. As you see, this is the single movable pulley. The effort is applied here where the load is here. So in this, the load is the multiplier of the effort. I hope that's clear. So load is just equals to twice of the effort. So this is the single movable pulley. So one of the pulleys gets to be moved and the other just withstands the effort that is applied just to move the load. Talking about the mechanical advantage and the velocity ratio, mechanical advantage is equal to load upon effort. So, but we know that in this kind of a pulley, load is equal to twice the effort. So MA is equal to twice effort upon effort. So MA is just equal to 2. While the velocity ratio, distance moved by effort, is likewise upon distance moved by the load. Same goes to the mechanical advantage and the velocity ratio. So when the effort moved a distance x and the load moved a distance a half x, if you substitute the values, so velocity ratio is equal to x upon a half x. When you work it out, so VR is equal to 2. So mechanical advantage and the velocity ratio are most likely the same in this kind of a pulley system. Last but not least, the third one, that is the block and the tackle system of pulley. Now, when two or more pulleys are fixed in a frame, a block is formed. As you can see, this is the diagram of it. Now, the pulleys in each block are fixed independently on separate axles. So, as you can see, each kind of pulley are just fixed in separate axes. So this is the block and the tackle system of the pulley. That's how it looks like. The load is lifted from here and the foot is applied from here. So that's how you can see this, the block and the tackle system of pulley. Now note that the mechanical advantage in this is equal to load upon effort, and the velocity ratio of block and the tackle system is equal to the number of the pulleys. So when the number of the pulleys increase, the velocity ratio will also increase, or if you reduce, they will likely reduce the velocity ratio of this kind of a system. Now let's see the example. A block and tackle pulley system has a velocity ratio of 4 if the load of 200 Newton is raised by using a force of 75 Newton. You are required to calculate the mechanical advantage of the system and the efficiency of the system. Now solution that are given, the velocity ratio given is 4, the load is 200 Newton, the effort is 75 Newton. Required to find the mechanical advantage and the efficiency of the block and the tackle pulley system. So mechanical advantage is equal to load over effort. MA will be equal to 200 Newton upon 75 Newton. So MA is just 2.67. While the efficiency of the machine, we say generally is equal to MA upon VR times V 100%. So efficiency will be equal to 2.67 upon VR times V 100%. Now we get it that VR from there, so the efficiency of the machine will be simply equal to 66.75%. I hope that's clear. So that's all I have for this session. We've discussed the pulleys as other kind or different type of the simple machine. We've seen that there are 3 kinds of them or types of them, how you can find the mechanical advantage and the velocity ratio of each one of them. I hope that's so clear, and thank you.